Welcome, my friends. Let's say the sum of two numbers is 45. The first number is 4 times larger than the second number. What are the two numbers? Let's use x to represent the smaller number and y to represent the larger number. The first statement is that the sum of the two numbers is 45. That means that x plus y must be equal to 45. The second statement is that the first number is 4 times larger than the second number. Since I said y would represent the larger number, that means y is 4 times as large as x, or y is equal to 4 times x. This problem lends itself to substitution, as our second equation is already solved for y. We can substitute y is equal to 4x into y from our first equation. We are left with x plus 4x is equal to 45. Now we have an equation in terms of only x, and therefore can solve the equation for x. X plus 4x is 5x, so we have 5x is equal to 45. Dividing each side by 5, we have x is equal to 9. We can plug x equals 9 into either of our original equations to solve for y. I'm going to use our second equation, which is y is equal to 4x. But we just found out that x is equal to 9, so that means y must be equal to 4 times 9, which is 36. Therefore, the two numbers are 9 and 36. Let's try another one. There are 40 students in an algebra class consisting of only freshmen and sophomores. The number of freshmen is 14 more than the number of sophomores. How many freshmen and sophomores are there in the class? Let's let F represent the number of freshmen in the class, and let's let S represent the number of sophomores in the class. We are told that there are 40 students in the class. Therefore, F plus S must be equal to 40. We're also told that the number of freshmen is 14 more than the number of sophomores. Oftentimes, the word is in a word problem represents an equal to sign. So we have F is equal to for the number of freshmen is. We are told that the number of freshmen is 14 more than the number of sophomores. S is the number of sophomores, but the number of freshmen must be 14 more than that. So we have F is equal to S plus 14. We notice that the second equation is already solved for F, which indicates that this problem can be solved by substitution. We can substitute the expression of S plus 14 into F in the first equation. That leaves us with S plus 14 plus S is equal to 40. Adding the two s's together, we have 2s plus 14 is equal to 40. Subtracting 14 from each side, we have 2s is equal to 26. Dividing each side by 2, we have s is equal to 13. Now we can plug in s equals 13 into either equation to solve for f. I'm going to use the second equation. We have f is equal to 13 plus 14, which means f must be equal to 27. That means there must be 27 freshmen and 13 sophomores in this class. Let's try a few more. A thrift store sells discounted hats and gloves. If the total cost of 5 hats and 2 pairs of gloves is $23, and the total cost of 3 hats and 8 pairs of gloves is $58, find the cost of each item. Let's let H represent the cost of a hat in dollars, and let's let G represent the cost of a pair of gloves, also in dollars. It wouldn't be a bad idea for you to pause the video at this point and see if you can determine the two equations that are described in this problem. Okay, hopefully you've given it a shot. The first statement tells us that the cost of 5 hats and 2 pairs of gloves is $23. We already stated that each hat costs each dollars, so if 5 were purchased, the cost of those 5 hats must be 5 times H. For the gloves, each pair costs G dollars. So if 2 pairs were purchased, the cost must be 2 times G. Altogether, we are told 5 hats and 2 pairs of gloves must cost $23. So adding those two costs together must be equal to 23. The second statement is very similar. We are told that 3 hats, or 3H, and 8 pairs of gloves, or 8G, cost $58. So our equation is 3H plus 8G is equal to 58. It would take quite a bit of work to solve for one variable here to use the substitution method, so let's try to use elimination instead. Remember that in order to use elimination, we need each equation to have the same coefficient on the same variable, just with opposite signs. If we multiply both sides of the first equation by -4 and distribute, we have a new first equation, which is equal to -20h minus 8g is equal to -92. The second equation hasn't changed, so I've simply rewritten it here. Now we have the coefficients on our g term that are the same in both equations, but with different signs, -8g and +8g. Now we can add our two equations together to eliminate the g variable. We get -20h plus 3h, which is equal to -17h from adding the h's. The g's cancel since we have -8g and +8g, which add to 0, and the constants are -92 plus 58, which is equal to -34. Dividing each side by -17, we have h is equal to 2. Now we can plug in h equals 2 into either of the two equations. I'm going to use the second one. That leaves us with 3 times 2 plus 8g is equal to 58. We have 6 plus 8g is equal to 58. Subtracting 6 from each side, we have 8g is equal to 52. Dividing each side by 8, we have g is equal to 6.5. Our final answer is that hats cost $2 each, and pairs of gloves cost $6.50 each. Let's try one more problem. You would like to rent a moving van and are considering two different companies to rent from. The first company charges a $120 fee to use the van for the day, with an additional 75 cents charged per mile. The second company charges a $150 fee to rent the van, but only charges 60 cents per mile driven. At what number of miles will the two rentals cost the same, and at what cost? Well, let's let C represent the total cost of renting a van in dollars, and let's let M represent the number of miles driven. Again, it wouldn't be a bad idea for you to pause the video to see if you could determine what our two equations will look like. Alright, we are told that the first company charges $120, meaning that our cost, C, is equal to $120 for company 1. But in addition to the flat $120 fee, an additional 75 cents is charged per mile. That means for each mile driven, another 75 cents is charged. So 1 mile driven is 75 cents, 2 miles driven is 75 cents times 2, 3 miles driven is 75 cents times 3, or in general, M miles driven is 75 cents times M, or 0.75 M, since our cost is in dollars. This must be added to the $120 as this is an additional cost above the flat $120 fee charged. For company 2, the total cost is $150 plus an additional 60 cents per mile driven, which can be written as C equals 150 plus 0.6 M. Now, we want to find out where these two costs are equal. There are a few ways that this problem could be solved, but perhaps the most straightforward way is to use substitution. Both equations are solved for C, so we can simply set the two equations equal to each other. Or if you want to think of it in terms of substitution, substitute our expression for C in one equation for C in the other equation. That leaves us with 120 plus 0.75 M is equal to 150 plus 0.6 M. I'm going to do two steps at once here, so watch closely. I can subtract 120 from both sides and subtract 0.6 M from both sides. This will cancel the 120 from the left-hand side and cancel 0.6 M from the right-hand side, which will leave us with 0.15 M is equal to 30. Dividing each side by 0.15, we have M is equal to 200. That means when 200 miles are driven, the cost is the same for both companies. That answers the first question, and we can answer the second question by plugging M back into either equation. Let's use the first one. We have C is equal to 120 plus 0.75 times 200. This simplifies to 120 plus 150, which is equal to 270. Our final answer is that the cost of renting a van will be $270 for both companies when 200 miles are driven. Alright, my friends, That completes our discussion on word problems related to substitution and elimination.